This video is to support you with facilitating lessons 61 through 63 of the 6th grade Excel curriculum. In lesson 61, students are jumping into additional practice with writing and evaluating numerical expressions. In this lesson, there aren't examples for you to guide students through. They are jumping right into practice. Since they've been out of school for a week, it might be helpful for you to model or refresh their memory around exponents. But what's critical here is you want to make sure students are using scratch paper. As you're lapping and supporting students, you want to make sure that they are solving problems in the correct order. So for example, if we look at question 23, it's going to be really important that students evaluate the exponents first, then they do the division, and then they subtract. So make sure students are setting their work up clearly and following their correct order. When they see questions like question 24, students will see questions like this on ANET. They will see questions like this on CAPE. You are going to look for not just the right answer. Here you want to pay attention to their work. And you are looking to make sure that students evaluated the expression in every single answer choice. They are going to complain. They are not going to want to do it. That's okay. Make sure it happens because that's the way they ensure they have the correct answers. So that's what you want to focus on in lesson 61. As you jump into lesson 62, students are writing and solving equations. In the first set of examples, students are testing solutions. And so they are asked, is 148 a solution of the equation x divided by 4 equals 37? And so you have to teach them a number is a solution if when I plug it in, it makes the equation true. So they're going to practice substituting. They're going to substitute 148 for x. When they do that, they find out that the equation is true. So when you get into the discussion, explain why it's going to be important that students actually do the substitution. And when they do that, they will find out that the answer is actually 38, which does not equal 37. Example B pushes them to do more substitution. In this case, they have multiple numbers to substitute so that they can identify if any of the numbers are solutions to the equation. As they jump into practice, numbers 1 through 8 look exactly like examples A and B. So when they practice, I would push students to do questions 1 through 8 first. You'll lap and support them. I would then pause and model question 9 because it looks a little bit different than the examples and students might get confused. The first thing that you want to do is make sure you read the directions and define inverse. Inverse means the opposite operation. So you'll ask, if we're adding, what's the inverse of addition? You want to hear subtraction. What's the inverse of subtraction? You want to hear addition. You'll do the same for multiplication and division. And then you want to model question 9. I see 17 plus k equals 54. In order to solve this, I need to use inverse operation, so I'm subtracting 17 from both sides. And you want to use here, what I do to one side, I do to the other. So I subtract 17 from 17 and from 54 to get my answer. Modeling that for students is going to set them up for success for questions 10 through 17. As you jump into lesson 63, students are writing equations in preparation for solving them. So students are going to see a number of word problems. So in this example, Logan has 28 cars. He's given more cars, which gives him a total of 31. We need to figure out how many cars did Logan's grandparents give him. Check students' comprehension. Ask them, what are we solving for? Make sure they know what they're looking for. And then follow the model. They choose a variable. They write the equation. And you might want to model for them. I have 28 cars. I'm given an unknown amount. Given that's what I don't know, that's where I put my variable for a total of 31 cars. And then you can model how to subtract, which will feel very familiar because you just modeled this in the lesson before. You are going to follow the exact same process as you jump into the problem-solving problem. And then you'll use that to support students with the practice. In the practice, you want to make sure that students have scratch paper, they set it up the same as ANET, that they are not using mental math, that they are actually setting up the problems and solving the problems. You want to see kids doing the inverse operations on both sides of the equation. Students are going to look at question 20 and say, this has fractions, I don't understand. And you're going to say, you do understand. Because we know the process, we just have to do it differently because we have fractions. And so that's what you want to pay attention to. As students jump into questions 26 through 31, you want to pay attention to their equation and make sure they have the correct equation set up, and then look at their work to make sure they're solving it correctly. So that's going to be really important for students. So the big idea in this lesson, which is a culmination of all the lessons, is ensuring students are setting problems up correctly, ensuring that they're using inverse operations to solve their equation, and they're showing all of their work.